you spend hours perfecting a design. On your screen, the colors are vibrant and every detail is exact. But when you hit print, the physical page comes out looking like this: faded, color-shifted, and plagued by visible lines. Your immediate reaction is probably to run a dozen print head cleaning cycles. You double-check your file resolution, swap out the ink cartridges, and wonder if the hardware itself is defective. Here is the frustrating reality. The digital math of your source file is completely pristine, and the mechanical hardware inside the printer, it is functioning exactly the way it was engineered to. If the code is flawless and the machine is doing its job, there has to be an unseen variable actively sabotaging your image between the glowing monitor and the paper. The root cause of a ruined print is often a subtle shift in the room's environment that changes the physical behavior of the ink the moment it leaves the nozzle. To find the culprit, we must scale down, past the plastic casing, and right down to the microscopic level of the printer's hardware. Down here, the metallic printhead hovers just mere millimeters above the paper, firing thousands of individual ink droplets every single second at highly specific, mathematically calculated targets. But there is one environmental condition governing this entire firing process: temperature. Ink is a reactive chemical fluid that is highly sensitive to the thermal conditions around it. Inside this tightly confined microenvironment, minor changes in ambient temperature trigger a physical chain reaction. This failure begins with a temperature shift of as little as 5 degrees. That tiny shift alters the ink's viscosity. Viscosity is a fluid's resistance to flow. It determines how easily the ink moves. When temperature changes, the ink becomes microscopically thinner or thicker than expected. Your printer is calibrated to push ink out at one exact thickness. When that consistency changes, the ink exits the nozzle at the wrong speed. Because the printhead moves rapidly across the page, timing is critical. If a drop falls even a fraction of a millisecond too fast or too slow, the paper continues moving beneath it, and the ink misses its targeted coordinate. When this miss is multiplied by millions of individual droplets, the final image suffers color mismatches, visible horizontal banding, and a loss of fine detail. The final print isn't the result of a mechanical glitch. It is a moment where fluid dynamics simply overrode the digital instructions. Your digital screen exists in a stable, mathematical environment. The physical page, however, is subject to the conditions of the real world. High-end printing is not just a data transfer. It is an active exercise in thermodynamics. Achieving professional-grade, perfectly color-matched results requires moving beyond the digital file and actively managing the physical environment where the ink meets the paper. Top-tier print professionals utilize specialized control systems built to stabilize these thermal variables. To consistently achieve flawless output, you have to master temperature control. In the next video, we will look at the exact precision systems the pros use to keep their ink consistent.